derivatives of inverse trig functions. Now this topic is a very minor topic. It deals with inverses, and inverses are also connected to implicit differentiation. I'm actually going to show you the proof of these ones, just because the application of it is something that's, I want you to see how we did our previous lesson when we did the ones with the tables and how that still works, as well as how that also connects to the implicit differentiation method with inverses, which I didn't get to show you. But do note that overall, you don't need to know that the proof part of it. It's more of a memorization piece, and you should be okay with just understanding that. So we're going to be focusing only on the three major functions: sine, cosine, and tangent. And so we're going to be focusing on y equals inverse sine of x. It's not reciprocal. Y equals inverse cosine of x, and y equals inverse tangent of x. These are the inverse tangent, or not tangent, inverse trig functions. So each of them just undoes the original functions. So when talking about, and we haven't really done it much in our course yet, but if you were with me over the summer, you would have seen that. So when we were talking about things like the unit circle, and let's say we had this coordinate right here at pi over 3, which was 1/2 comma square root of 3 over 2, and from this it shows that, for example, the sine of pi over 3 is equal to the square root of 3 over 2. Well, for the inverse sine of square root of 3 over 2 would therefore be pi over 3. So it kind of like undoes the feature, and it goes backwards. All right. I don't want to get into it too much, as we can do a whole multi-day lesson just around inverse trigonometric functions. I don't know how much we're going to need to utilize the unit circle and trig, as I mentioned. I do just want to cover it, and of course, if you were with me during the summer, you probably have a much more solid understanding of what I'm trying to get through with these pieces of information. Basically, and this is more of, like I said, the proof. If y is equal to the inverse sine of x, all it means is that the sine of y is equal to the x. So if you recall from your algebra days, if y equals sine of x, then the inverse is where you switch x and y, and then you solve for y. And so when you solve for y, you get to, which is called the inverse sine. So you just take the inverse sine of both sides. The sine and inverse sines cancel each other out, and you're left with y equals inverse sine. However, we're going to focus on this version right here. So these are equivalent. Y equals inverse sine of x is equivalent to the sine of y is equal to x. Now, this is very important because we can actually draw a picture of this. What it's saying is that we're going to call the angle y. And it says that the sine, and sine is opposite, is equal to x. So the opposite is x, and the hypotenuse is therefore 1, opposite over adjacent. So sine of y equals x, this is a picture of that represents that. If I were to look at this right triangle, it follows that the sine of y is equal to x over 1, which is, of course, x. Utilizing the Pythagorean theorem, it follows then, therefore, that the other side has to be the square root of 1 minus x squared. That's just the Pythagorean theorem into work, the relationship that a squared plus b squared equals c squared, or therefore b is equal to the square root of c squared minus a squared. That's just Pythagorean theorem relationships. All right, so now that we have that picture, we can actually differentiate. And what I mean there is we're going to take the derivative of the sine of y and set that equal to the derivative of x. So it's an implicit differentiation, right? What do I get on the left side of this derivative? What is the derivative of sine of y with respect to x? This is where I need participation. What is the derivative of sine of y? That's a straightforward derivative.
Is it cosine?
Cosine of what?
Y.
Okay, cosine of y what?
dy dx.
Thank you, dy dx. This is implicit differentiation. So cosine of y times dy dx. There we go, times dy dx. There we go, equals what?
0.
No.
X.
No. It's the easiest,
1.
yeah, just the easiest derivative, one of the easiest derivatives we have. The derivative of x is just 1. Divide by cosine of y on both sides. And we get that dy dx is equal to cosine of y. The problem, so that is the derivative. 1 over the cosine of y. People doing landscaping work outside. That's the derivative, but that's not in terms of x. So let's say we now want to find this in terms of x. Well, from this picture over here, what is the cosine of y? Cosine of y is adjacent over hypotenuse. So what is the cosine of y based on this triangle that we've already drawn from our original relationship that sine of y is equal to x? What is cosine of y?
Would it be just the square root of 1 minus x squared all over 1?
Perfect. Adjacent over hypotenuse. So now the derivative is 1 over that. So the derivative is 1 over cosine. So it follows that dy dx is therefore 1 over dy dx is 1 over cosine of y, and cosine of y is square root of 1 minus x squared. So dy dx would be 1 over
square root 1 minus x squared.
And that's our answer. The derivative of the inverse sine of x is equal to 1 over the square root of 1 minus x squared. That is the rule. Now, I hope all of you can follow what we've done. Okay? That's my hope. That's the goal. That's the dream. But it's not the goal. The hope and dream is that you followed everything and why we got to what we got to. All right? We utilize this idea of implicit differentiation that we've already learned. We did some right triangle trigonometry, which is a requirement for the course, but we've kind of put it on our back burner. And then, of course, we resolved and, we did some nice, good math trigonometric relationships in order to get it back down to square root of 1 minus x squared. So 1 over that. Overall, though, you can just memorize this, and that's really what's most important. So we've just found our first derivative, that the derivative of, and I'm going to write it again on the next page, the derivative of the inverse sine of x is 1 over the square root of 1 minus x squared. This is the first memorization one. It also follows that the derivative with respect to x of the inverse sine of u would just be the chain rule. So it's 1 over the square root of 1 minus u squared times du dx. So that's just the chain rule version. So like if it's not x, you do the same thing times the derivative of that baby. And like I said, it's a memorization piece. We can also do it with the derivative of inverse cosine of x. And this is just another way to do, I could do the proof the same way on this one right here, but cosine, so if I call f of x inverse cosine of x, then the inverse would be cosine of x. Okay, so the derivative, so f prime of x, which is, sorry, I didn't want to write it that way. The inverse would be cosine of x. Therefore, f prime of x would be equal to 1 over, oh, sorry, you know what, I wrote this backwards. Sorry, let me just fix this part real quick. If I define inverse cosine as the inverse of f, with f being cosine of x, hold on, let me close my windows. Much better. Then the derivative of the inverse is 1 over f prime inverse of x. While f prime, the derivative of cosine, is negative sine of x. So then that means that this is equal to 1 over negative sine of the inverse cosine of x. Like I said, this is a proof. If you're having trouble following it, it's not a deal breaker in regards to the course or or doing the work, but it's something that really expands your knowledge. And I wanted to do so. Then so as we can see, our answer is going to be negative. All right. Now the same kind of relation holds true here, in that if I define cosine as being this, then our picture, we call this y, and this, therefore the adjacent is x, and this is 1, so this is the square root of 1 minus x squared right there. And it says we're going to take the sine of this, or the negative sine of this, and so I know it's a little bit weird, but the negative comes from there, and then I get 1 over, and then the sine of using this picture would just be the square root of 1 minus x squared as well. And so we get that the derivative of inverse cosine of x is, and I hope you notice it, it's basically the same thing as the inverse sine, but with the negative. And so the derivative of inverse cosine of x, inverse cosine of u would be negative 1 over the square root of 1 minus u squared times du dx. And that's just a chain rule version. So the second proof I did using the same rule that we did in terms of finding the derivatives of an inverse function using tables. That was how I did that proof. The previous one, I proved using the concept of just implicit differentiation and not just going directly to the rule. So I did it more the longer way. Both of these parts where it comes down to the proof, you don't need to know or memorize. You're not going to be tested on them. It's good to know and be able to do moving forward, like when you go into college, but it's not anything that's going to be make or break. More importantly, this is a memorization. And this is a memorization. Okay, so memorize those two. And finally, the other one, I'm just going to tell you what the answer is. We could prove it the same way. And it's that the derivative, but just like I said, it's just a memorization. The derivative of inverse tangent of x is 1 over 1 plus x squared. So therefore, the derivative of inverse tangent of u is equal to 1 over 1 plus u squared times du dx. Memorize them. Okay. Memorize them. That's what it comes down to. So in the end, these are just 3 new derivatives that you need to memorize. And if it's chain rule, you should understand how the chain rule works. Now, it should also be I also want to note something. Inverse cosine of x can also be written as arc cosine of x. Inverse sine of x can also be written as arc sine of x, that are same equivalents. And inverse tangent of x can be written as arc tangent of x. The AP exam, on the first page that you open for the AP exam, notes that when you see this notation, it refers to arc cosine, or that they are the same thing. So arc cosine, inverse cosine, they mean the same thing vocabulary wise. All right. So let's do 2 examples and we'll call it a day. It's very short. It's all about memorization. So ideally you memorize them and don't have to look at a piece of paper, but of course if you need to reference the derivatives, you should be able to do so. The biggest thing that people make mistakes here is the parentheses. The parentheses are typically the biggest mistake that happens. So let's do an examples. Let's do our examples. The first one is we're going to find the derivative, and these are typically one multiple choice question. So in the end, it usually turns to be one single multiple choice question. I personally have not seen these questions on free response. It could be, but I have not seen them. Of course, the exam is ever changing and evolving, especially during these times. So we need to realize that. So the question is, what is the derivative of arctangent of 4x? I'm trying to interchange the vocabulary so that you can see it. So that's the question. Now we know that there's no square root with tangent, with arctangent, and it's a plus. Those are the type of things I memorize. So it's the plus, 1 plus, not the square root of 1 minus. So square root of 1 minus or 1 plus. That's how I pretty much decipher the two. So this is straight memorization. What is my answer? How do I do it?
plus r tan x.
No. What is the derivative of arctangent of 4x?
Just r tan 4.
No, the derivative does not have any arctangent. The derivative arctangent does not have an arctangent in it. You can see very clearly right here, the derivative of arctangent does not have anything with arctangent.
Would it be 1 over?
1 over
1 plus
1 plus. Now be very specific on your next thing.
the 4 squared?
What is that?
And like in parentheses, and then on the inside 4x, and then square it.
Like that?
No.
How?
Like close your parentheses, and then put your square.
There you go. Okay.
Okay, and then you have to do the derivative of your baby, so times it, and it'll just be 4.
Good. Let's clean it up. Let's get rid of parentheses and make it into a single fraction. For multiple, like I said, it's going to be multiple choice. You would not see this on as one of your choices. So what is the answer as one single fraction without any parentheses?
I just put 4 over 1 plus the 4x squared.
No parentheses.
1 plus parentheses 4x.
No parentheses.
With no parentheses?
Yes, it's undo the. It's evaluate it. No,
Would it be like 16x squared, something like that?
no, it is. It's not something like that. It is that.
Oh.
So 4x quantity squared is 4x times 4x, which is 16x squared. Or you can think of it as squaring the 4 and squaring the x. So 4 squared times x squared, which is 16x squared. And that's it. It's a memorization. It's a memorization. Usually, like, and these come down to with these ones, there's not really anything fancy to do. Now, I could do something with product rule, as I'll do in my next example. Questions on that? Questions on what we did to solve that problem?
Not very interesting.
It's just memorization. Like I said, it's just memorization. There's a rule, and you just follow the rule. Why is that rule? That's it.
You know, I need to see that video again.
What is that?
Remember every. I need to see that video again.
You don't need to know all that other stuff. You don't need to know all this. This is what I've been very specific about that. You don't need to know all this proof stuff. Now, it's very helpful, and it's important in the long term if you want to be long-term successful in college calculus. But in the end, you have 3 rules. The 3 rules that and it's just a memorization. That's all it is. Next example. Y equals x inverse cosine of x squared. Find dy dx. All right. How do I do this?
Would it be the derivative of x cosine inverse of x squared equals 1, no, negative, and then 1 over the square root of 1 minus x squared, and then we take the baby, I guess.
You're missing something. You missed something in the beginning. Can anybody identify what's first thing it's missing? What's the first thing we need to identify and apply?
Is it sine?
No.
Oh, it's an x in the front. It's a product rule.
It's a product rule. If you don't recognize this as a product rule, you've already got it 100% wrong. It doesn't matter what you do within the problem. Like I said, these are multiple choice, but even if you don't identify a product as a product rule in differentiating, you're not going to get any credit on the AP exam. It'll be a 0 right from the get-go. So you've got to make sure, first and foremost, that when you look at a problem, while you may be like, oh my gosh, there's an x and a cosine inverse, you've got to recognize, okay, first off, it's a product rule. U prime v plus v prime u. So equals bracket, parentheses, plus bracket, parentheses. All right, so that's my u, and this whole thing is my v, and my v requires chain rule in regards to what was being done. All right, so what is my derivative?
Wouldn't just be cosine -1 of x squared?
No, it's first it'll be just 1.
Okay, times your cosine of -1 of x squared.
I'd like for you to say inverse or arc, one of those two. When you say to the -1, it sounds like it's actually like a reciprocal, so you just got to be careful about that vocabulary-wise. So inverse cosine of x squared, or arc cosine of x squared, however you want to say it. Either way, they're equivalent. Plus.
Okay, now would it be the 1 over?
-1.
Yeah.
Over.
-1 over the square root of 1 minus x squared? No.
Anybody?
So it's dy dx.
No, there's no dy dx.
No, I didn't try.
Well, would it be x to the 4th or something?
There you go. There you go. X squared squared, or as Ariana realized, x to the 4th it will become. It's x squared is the baby, so it's x squared squared. Gotta be careful of that. Times, I don't see anybody has the next one.
2x
times,
and then times your x.
2x, because that's the derivative of x squared. The derivative of the x squared is 2x, so we have to multiply by 2x. And then times what?
Your x.
Times
x.
my x. Times my x from my u. Very good. So that's the answer. I mean, that's what it is. Of course, we want to clean this up. dy dx is equal to inverse cosine of x squared minus what? Let's clean it up.
Would it be 2x squared all over the square root of 1 minus x to the 4th? X to the power 4th?
Yep, that's it. As clean as we would want to go for our class, and that is the derivative. So it's product rule. It's about making sure that you're doing it correctly, that you're taking each part step by step. That's basically as much as I need to cover for you. Anything else? Well, I can actually do one last example. F of x is inverse sine of x over 3. Let's find f prime of x. Okay, we'll do this last example here. Now this one's a lot, I mean, this should be easier than the previous one, but because it has a fraction, it always freaks everybody out. And of course, I want us to simplify it down, because on a multiple choice, we might do the right work, but then not be able to find the right answer, or manipulate it down to a single fraction. All right, f prime of x is equal to what? Just follow the rule. It's a memorization. You have the rule in front of you. You have it written down in your notes, or you better have it written down in your notes. And all you got to look is say, oh, the function is inverse sine. The derivative of that is, and you just rewrite it and input what the function is. If there's a baby that it, which this problem has, chain rule, apply that chain rule and apply that, you know, as it should. And there's really nothing to do but copy it. You're really only just copying, and there's a very, very, very small piece that you're actually having to do on your own. So what is my derivative?
Would it be 1 over the square root of 1 minus parentheses x over 3 squared?
X over 3 quantity squared.
And then times, I know this is right, but is it 1/3?
It is 1/3. The derivative of x over 3 is the same thing as 1/3 x. All right, so it's just the derivative is 1/3. Perfect. Of course, so we just literally applied it. We just put in place of the x, we put x over 3 because there's a baby in parentheses, and then we multiply by the derivative of what was inside parentheses, which is 1/3. Cleaning this up now, it gives me 1 over 3. That's the 1/3. Square root of 1 minus what?
Can we keep the other one the same?
No, we want to get rid of parentheses.
Would it be just x squared over 9?
X squared over 9. Very good. Now, to do this, we need to, there's a couple things that we can do, but the easiest one is just to pull the 3 inside the square root. All right, so when we pull the 3 inside the square root, it actually becomes 9, because the square root of 9 is 3. So when we put the 3 inside the square root, it becomes the square root of 9 times 1 minus x squared over 9. This is just a math way of doing it, which gives me 1 over the square root of 9 minus x squared. This is how you would probably see it on a multiple choice. Another way of doing this problem, in terms of rewriting it, another way of doing it on this problem is once we get here, we can think of this as 1 over 3 square root, and then we do a common denominator, which would be 9 over 9. So this would be 9 minus x squared over 9. You can do it this way, which is 1 over 3 times the square root of 1 over 9 times the square root of 9 minus x squared. And these two cancel each other out, leaving behind 1 over the square root of 9 minus x squared. So that's all. That's algebra manipulation. Okay, that last part. These are problems where when you look at the answer and it's 1 over the square root of 9 minus x squared, I hope that you're able to do that algebra, but I do know that that's a hard step. How do you get what we see here? This is what I get when I do the work, and I've done the work correctly, but that's not an option, and I have to recognize that this is going to be this over here. Now, most of the time, you can just eliminate the other multiple choices. You look at them and you say, well, it can't be any of those other ones. And then once I know that I can at least do this and get rid of and have it over 9, once you get to here, you should be able to at least look at the options that are on the problems and come down to right here. And, like one of them is going to be negative. So you're like, I know my answer is positive. So boom, there goes one of them. And then you should be able to recognize, oh, well, it's over 9. So maybe 9 is going to be in my denominator. Oh, and it is. It's 9 minus x squared. So there's that. Now,